In this video, I'm going to work through a few problems with the normal distribution. The question asks, in a normal distribution, what proportion of cases lie above 0.95? The best way to get started with these problems is to draw a picture of what you're looking for. Here I have a standard normal distribution, or the best I can do to draw one. And I want to know what proportion of cases lie above 0.95. 0.95 would be about here. And what I'm interested in is this area under the curve. So I want to know what's the probability that z is greater than or equal to 0.95. And if I go to my table, here I have an excerpt of the table from a statistics book. Every book has a different table. This one only gives values for positive values of z. There are no negative values. However, the normal distribution is symmetric, so it's very easy to obtain probabilities for negative values of z. In this case, I need to look up, using values in that first column labeled z, I need to find 0.95. And when I do, I can see it's right here. Now there's two columns where I can get the probability. Column A shows the area between the mean and z, and column B shows the area more extreme than z. In this particular case, I will use column B because I'm looking for values more extreme. So my probability will be right here. It's going to be 0.1711. So about 17% of the cases lie above 0.95. Let's look at another problem. This one is a little bit more complicated simply because of the way the table is presented. Here we would like to know, in a normal distribution, what proportion of cases lie above negative 1.03. I'll start again by drawing a picture. And I'm going to be on the negative side. And the proportion I want, or the area I want, is here. Now what makes this difficult is that the table only gives positive values. However, the normal distribution is symmetric. Therefore, values between the mean and 1.03 are the same thing as values between the mean and negative 1.03. So I'm going to look up a positive 1.03 in the table, and I have it here in the last row. And I'm going to use column B this time because what I want is I'll start with the area between the mean and z, and in this case it's going to be 0.3485. So the probability that z is greater than or equal to negative 1.03 is going to equal to 0.3485 plus 0.5. Now I'll get the 0.5 because that's this part here. All the area above the mean is 0.5. And so my answer is 0.8485. Let's look at another problem. And it's going to be slightly different. Here I would like to know, in a normal distribution with a mean of 45 and a standard deviation of 6, what proportion of cases lie below 41.58? So I would like to know the probability that x is less than or equal to 41.58. Now the problem is that the table is based on the standard normal distribution, but the problem is asking for a normal distribution with a mean of 45 and a standard deviation of 6. In order to solve this problem, the first thing we have to do is compute a z-score. So my z-score is going to be 41.58 minus 45, which is the mean of the normal distribution in question. And I'm going to divide by 6 because that's the standard deviation of the normal distribution of interest. And when I do that, my z-score is negative 0.57. So now I can look up the probability that z is less than or equal to negative 0.57. And if I draw a picture, again, I'm on the left side, or the negative side, negative 0.57. Because the distribution is symmetric, the area above 0.57 is the same thing as the area below negative 0.57. So what I'm interested in is this particular area here, the area below negative 0.57. If I find a z of 0.57 in the table, I'm here, and I will go to column B because I want the area beyond z, and that's going to be 0.2843. So that probability is going to be 0.2843. This particular problem should be somewhat familiar. What you're doing in this problem is computing a percentile rank. We basically just found the percentile rank for a score of 41.58, and that percentile rank was about 28%. Another thing we might want to know is how to compute a percentile point. We'd like to know what is the 70th percentile of a normal distribution with a mean of 100 and a standard deviation of 16. So what I'd like to know is I'm trying to find the value of x, right? So I want to find the value of x that has 70% of the observations below it. Now again, the table gives us values from a standard normal distribution, so I'm going to have to use the table to find a value of z and then apply a linear transformation to put the result onto the scale of x, which is a distribution that has a mean of 100 and a standard deviation of 16. So if I look at my table, I want to find the value of z that has a probability of 0.7 below it. If I do that, there's two potential values. I could use 0.52 because the area between the mean and z is 0.1985, and if I add 0.5 to that, I'm close to 70%. I could also use 0.53 because 0.5 plus 0.2019 would get me slightly more than 70%. Well, if we're using a computer, we can get the exact probability that we want, but these tables are limited. And we could do this in a way where we use linear interpolation to get the value we want, but to keep it even more simple, I'm going to use the rule of thumb that in this particular problem, since we're looking for a percentile point, is use the probability that gets you as close to the probability of interest without going over it. So in that case, I'm going to choose 0.52 because that gets me close to 0.7 without going over. If I use 0.53, I'm over 70%. So my value of z of interest is going to be 0.52. But the question is asking not for z, but it's asking for x. So we have to apply a linear transformation to get there. And so my value of x is going to be 0.52, which is my value of z, times this desired standard deviation, which is 16, plus the desired mean. And with that, I get 8.32 plus 100, and the final result is 108.32. So we know that a score of 108.32 is the 70th percentile on a normal distribution with a mean of 100 and a standard deviation of 16.